Good morning, everyone. Thanks for attending. Glad you guys made time for the talk today. I know it's been a long 2.5 days at the conference, but just a quick way of introduction. My name is James Perry. I'm the Senior Director of Professional Services at CrowdStrike. So what does that mean? I run our incident response, our strategic services, and our technical services business. So everything that we do where we go out and help clients who have an incident, want to know if they're prepared, want to know if they're ready for a cyber breach. Those folks work for me at CrowdStrike. But today, I'm going to take a little different spin on this and talk to you about how we use identity. First, kind of walking you through what does that even mean? What are the types of identities that may exist in your environment? And then at the end, talk to you about how we can help. How does CrowdStrike and our technology help with speeding up the speed, increasing the speed of containment, and helping companies reduce business interruption? Really, how do we keep companies from having to shut down their entire network during a ransomware attack? So let's first talk a little bit about, why does it matter? Why do you care about identities? What do they mean? So there's a talk that Rob Joyce gave back in 2016 at the Enigma conference where he made a point that said, you need to know your assets. You need to know your network. Organizations spend a lot of time knowing what software should be running on your network. Adversaries spend a lot of time understanding about what software they can run on your network. The same goes for identity. We have many organizations who do assessments. They understand what accounts are supposed to do what, why they created them, what they should be doing. And then adversaries will come in and decide what they can do with that account. What can they do with the privileges that are provided to a particular identity, a particular user or service? And that's what we have to understand as we talk through identity. So just a little bit of stats here. So, Forrester came out back in 2021 that said 80% of data breaches have a connection to compromised privileged credentials. I would say that in the instance that we work, nearly 100% of our incidents involve compromised credentials of some kind. It's no longer that privileged credentials are what you need to protect. You need to protect every credential in your environment. A simple user who may not have the ability to access a domain controller or run privileged code on a system still may have access to your finance file share or your HR file share. And that's the type of information and data that actors are after these days. When a breach comes from a stolen compromised credential, according to cost of breach in 2021, it takes 250 days to detect. And that, kind of a weird stat, because right now what we see is that companies are detecting incidents very quickly. And that's because actors steal data, they encrypt systems, they send you a ransom note. That's how most organizations these days, especially in the e-crime ecosystem, are noticing that their organization has been compromised. So, why do identities matter? Really two things. They're used to gain access, elevate privileges, move laterally across enterprise systems. You can't do that without an identity of some kind. Yes, you can exploit a system, with a CVE, but likely the system that came from you had to have an identity on in the first place. You have to be able to use legitimate user credentials to move on. What we're seeing a lot now is SSO. I don't know if any of you attended the Microsoft talk yesterday around cookie theft. All right, well, we lost that monitor. What we're seeing now is many organizations have moved to multi-factor authentication. They've moved to SSO, and actors are learning to exploit that. They know that if they get one simple credential, they're gonna be able to go to the Ping homepage, the Okta homepage, and see all of the applications that user has access to. And one thing that leads to is users that may not be a privileged Active Directory credential may be privileged in those applications. You can have a simple user in your finance department that has no privileges to do anything on their systems, but maybe they're a super admin in Salesforce. They're a super admin in your finance system in Coupa or something along those lines. Or a normal user that's a super admin in your Slack instance. So you have to worry about identities beyond Active Directory, beyond the endpoint. And SSO has made it a lot easier for attackers to move through networks and steal data from those cloud-based systems, from those SaaS systems, and not just from your endpoints. So why does this matter, and where can you stop attacks? And so that's what I'm going to walk you through a little bit here in a minute, is the different actors and how they use identities, how they steal identities, what those mean. Hopefully introduce you to some new concepts of different types of identities that you may not have thought of. But just starting on, thinking about how we can interrupt the transitions between these different phases of an attack and why identities matter. When an attacker moves from, installing malware to getting command and control or privilege escalation and lateral movement, there's many opportunities where legitimate user identities and user credentials are used in the transitions between those phases, where you can detect and you can prevent and you can stop ultimately the business interruption that happens with ransomware. All of these concepts apply not just to e-crime, they also apply to advanced persistent threats. Whether it's China or Russia or Iran or another organization coming after you, a lot of the concepts, things that we see ransomware actors using, we see advanced nation state actors using the same tools, the same techniques, same procedures as a ransomware actor. Why? An advanced actor is only going to be as advanced as they have to be. If they can get on a simple user workstation and use that credential to elevate privileges and access whatever their data they're after is, they can access that user's email account. They might not need a privileged credential for that. They may be after you and maybe going to get your username and password so they can access your email and read your email. The same techniques are used by both e-crime and nation state attackers. So let's talk a little bit about local admin privileges and the issues that we see every single week in our incident response investigations. So Cozy Bear is an actor that loves doing this when they come into the network and move laterally. We see many organizations where every user is local admin. Or not only local admin on their box, they're local admin on any box in which they have access to. So great, your users are local admin. Many organizations had to do that when we rapidly moved remote for COVID, so users could install printers, connect to systems, added software, because IT couldn't reach out and touch that system remotely. But we saw a lot of organizations accidentally, or maybe just for ease of use, make it so that Active Directory user became local admin on any system they accessed, including domain controllers in a couple instances. We also see enterprises that use the same local admin password everywhere. And they think, it's fine. That's a long, strong password. No one ever uses it. But then they share it across their servers. And organizations come in, hackers come in, steal one credential from one server that happened to be exposed externally, that had an unpatched CVE. They run Mimikatz. And suddenly, they have access to every single system, every single server that shares that password. So some things you have to walk out for, in kind of attack paths as they move from a typical user in your environment to someone with local admin. You have to have local admin to run and dump credentials with Mimikatz. You don't have local admin on that box, you've stopped one simple attack vector right there. And it gives you an opportunity to detect. Is a non-privileged user, someone who's not local admin, attempting to dump credentials. Most security solutions are going to catch that. Local admin is needed for most EDR bypass techniques. You can't touch system processes unless you're local admin. So if you want to get past EDR, you want to try to do some fancy thing, you're going to need local admin for it. And then also the duplicated local admin privileges. Like if a user admin gets on there, what do we see nowadays in a ransomware attack? They get on one system, they run MBT scan, they find the other systems that are there, and then they try the same local admin password. And it works way too frequently. It's a reason that our team is so busy every week. So how do you protect these? What are some of the things that you need to do? So we talked about this. What does local admin provide? Local admin privilege, for credential dumping on a system, you need local admin. You need to access the SAM database. You need to access the LSAS process that has hashes sitting there in memory. So all of these processes, something as simple as Task Manager. Every level of attacker that we track has probably used the technique of opening up Task Manager, right-clicking on the LSAS process and saying, create a memory dump. It's that simple. You now have a file sitting on disk that has, in some cases, clear text credentials, in most cases, the hashes that can be used to pass the hash or be cracked offline. You also need it for credential dumping. If you have local admin on a domain controller, it's really easy to get to the ntds.dit. You can perform DC sync, which is probably the most common method that we see at this point that attackers are using. It's one of the first things we see attackers doing after initial access. They're going to attempt to sync the domain controller. So protected user groups. How many people here know what protected user groups are in Active Directory? Yeah, a couple people. Most organizations don't do this. They don't use the protection of groups to not cache credentials on a local system. So if domain admins are logging in, their credentials are cached. You dump LSAS, it's there. You grab the SAM hive, it's there. Privacy protection on Kerberos, doesn't let you do offline authentication in some cases. So if the system's not connected to your domain, you're not going to be able to log into it. Prevents you from having constrained or unconstrained delegation, and you cannot authenticate using NTLM, which is the primary method that attackers will use when they're using pass the hash. Why do most organizations don't do it? You'd be surprised at the number of companies that still have their Active Directory domain below functional level 2012 R2. They have legacy systems, they need backwards compatibility, they have some .NET app that somebody wrote in 2006 that still runs their benefits website. They just never update their Active Directory functional level that doesn't allow you to have these additional protections that Microsoft has had for 10 plus years. I heard yesterday that the first time Microsoft put out the white paper on Pass the Hash was in 2012, which was 10 years ago. Most people still are not protected against it. Rob Joyce talked in 2016, he talked a lot about Pass the Hash. That was 6 years ago. Still a major issue. We still see it, pretty much on a weekly basis from some attack group or another. So what can you do, and how do you protect against this? So we talked about protected user group membership, but also having strong passwords. There is no reason in this day and age that administrators should not be using, and most users should not be using, a password manager, where they can use a strong 15-character plus password. Also prevents the NTLM hash from being stored. It doesn't know how to handle a 15-character password. You go to 15-character plus, even if you have older settings on your domain controllers, it's going to prevent that hash from being stored in your ntds.dit. You can do tiered administrator accounts. How many people in this room have had a vendor come in and say, hey, we're having trouble installing this software or this appliance. Can you just make my user domain admin? Because that, just to test to make sure it works. I've had vendors do that to me in my career, and it's no. Because what happens is you make the domain admin, it works. That vendor's there on a fixed fee, 3-week project. They say everything works and they leave. And then 12 years later, your network goes down because of ransomware. And what is it? It's some SVC account that had grossly over-permissioned privileges in the environment that the attacker was able to find and use to encrypt the organization. Separate your administrator accounts. Your help desk does not need access to domain controllers. Your server administrators most likely don't need access to domain controllers except in a break glass scenario. Your workstation admins, they only need access to workstations. Think about how you set up your network and your environment and your identities so that a simple user credential compromise or endpoint compromise doesn't become an issue in which you're calling my instant response or Mandiant's instant response hotline on a Friday afternoon. You don't want to have to do that. Privileged access workstations, they're great. Make sure users are only using their privileged access workstations for privileged access, and they just don't make it their day-to-day workstation. Make them ephemeral. Make them so the second they shut it down, that it blows it away, and the next time they need it, they get a new one. We see admins that, we're all, when you're in IT security or in IT, you tend to be a little bit lazy. You tend to find the easiest way to do something. If working from your privileged access workstation makes your life easier, admins, security administrators are going to do that. Use password vaulting, privileged session management tools. There's dozens of them out there these days. Use something where people don't have to put passwords.txt on their desktop. You would be surprised. Many cases that we work, one of the first searches that we run when we have a user we know is compromised, that username and the word password. And we look across the data that we've collected, and many times it comes back that on their desktop, in their documents folder, is an Excel or a Word document, or in most cases, just a text document called passwords. You open it up, and it is the keys to the kingdom. Use conditional access policies. So these, you can do that in Active Directory in some cases, but those really apply to your SaaS solutions. Things like, Office 365 have conditional access policies. Don't let admins log in from a workstation that's not managed by your environment. Attackers love things like Vulture and Chupa and cloud hosting providers. They just spin up a workstation and they'll use those compromised credentials to access your environment. Use conditional access policies. One of the best ones that you can do, you can actually block things on machines names in Office 365, prevent desktop dash systems from accessing your network. That's what, when you spin up a workstation in a cloud environment, most of the time they're named, Vulture guest, desktop dash a random number that's generated when you spin up that system. Look for those in your logs, block those in your logs if you're able to. 80 operator accounts. How many people in this room know what these are and why they are bad? So I'll switch to the next slide. Actually, go back. So there's many accounts in your domain. Domain admin's not the only one. These are four of the most common ones we see users added to that provide unnecessary privileges within the environment. Backup operators, print operators are two of the biggest ones. Account operators, server operators are the other two that somebody put them in that group because something they were trying to do wasn't working. Let me try this group. It says, hey, I need to install a print driver on my system. Let me add them to print operators and see if that works. And it will for most users. But what does it also do? An account operator can modify any account or group that is not a domain admin or operator. How many domain admin groups also have a group in it? Many that we see. So that account operator group can actually add themselves to a group that is a sub-member of domain admins, making themselves a domain admin. They can't make themselves directly a domain admin, but they can add themselves to a group. A server operator can, by default, access any server, including your domain controllers, including your security servers, including your backup servers. Like if it's a ransomware actor, they can use that to go in and delete your backups. It can modify services on a domain controller. We see it commonly where there's a stale service on a domain controller where the file no longer exists for that service. Operator will come in, change that service, point it to their own file or put their own file on disk, restart the service, and now they have privileged persistent access to a domain controller. A print operator. This is one that I think our red team really enjoys this account when somebody does this because what it allows you to do is install a print device drivers on a domain controller. Not just printer drivers, device drivers. You can install basically any device driver on a domain controller with the print operator group. It gives you that level of access. People don't realize that when they're creating these groups. It's one of the problems with Active Directory. It's confusing. Backup operator. Best thing for a red team, an attacker about that is that they can restore the ntds.dit from a backup. You get that, you have the keys to the kingdom. You now own the network. You now have to reset all passwords, roll the Kerberos ticket. It's a very bad day for a security and technology team when you see the ntds.dit walk out the door in an environment. Oops, wrong button. So NTL and relay attacks. Let's talk about those a little bit. So how many of you in this here block just basic authentication from leaving your network? You block outbound port 445, 135. A couple people. We've seen advanced nation state actors do this. Russian actors love this. They'll send you a link. You click on it. It tries to get you to log in to that site using basic authentication from Active Directory. What that does is it sends your NTLM hashes out the door. So your actor sitting on an external interface, they'll host a JPEG, in their email that's actually on a file share. So it's going to make that authentication request out. They're going to be able to intercept your hashes, potentially relay those back and pass them back to authenticate to another resource. Block outbound internet access from your systems. Don't let 443 go out. Let things go out of proxy. Don't let anything else go out the door. Attackers are crafty. They learn ways to do this. We see widespread phishing campaigns about this, every few months from targeted attackers against organizations. And, as it says up there, there's many variations of this. It's a very basic attack. People have been using this for, probably since the early 2000s. It still works this day. Sophisticated nation state actors would not be using it if it wasn't still working. So it's obviously still working. We also see it when actors get inside the environment using something like Responder to intercept hashes on a domain controller to allow them to later pass the hash. Our red team uses that all the time. So what can you do? One, you can block this with Falcon Identity. We'll talk a little bit about that later. Require SMB signing domain-wide. Most organizations don't do this because it'll probably break something on that server 2003 box that's still sitting around in their environment. Use LDAP signing, LDAP channel binding on all your domain controllers. Most people don't do that because it's an extra step. And protect your AD certificates. There's extended protection authentication on all your systems. Require SSL when you're doing connecting to your AD certificate servers, and disable end-to-end authentication if you can, particularly on your AD certificate servers. So let's take another step and look at our account configurations, or in the cases that we see, misconfigurations. So service principal names, always something that we love to use during red team attacks. They're very vulnerable to Kerberos roasting. What do you do about that? For your service accounts, limit the privileges that they have. If they don't have to have any access except one box, don't let them access anything but one box. Use strong passwords. Use AES encryption type on for anything accessing those accounts. Strong passwords are a very big thing here. The longer the password, the harder it is to do things if you're able to obtain it. Always enable Kerberos pre-authentication. Once again, use strong passwords. And then reduce where you have with unconstrained delegation. If you have accounts that have unconstrained delegation, they're able to access resources on behalf of other users. They're able to basically as a service account, take control of the privileges that other user has. Disable that, reduce it, only use it if you need to. Very few cases do you actually have to have that unconstrained delegation used in your environment. I don't know if I've ever seen an actual use case where you need it, where you can't get by with using configuring constrained delegation. It's sort of like the domain admin world. It's like, well, let me try to do this. Let's see if it works. If it does, your ProServe vendor's out the door and you're stuck with this 10 years later and calling an incident response firm. So that gets me closer to the end. So I'll talk to you a little bit about how CrowdStrike can help with this. Like why am I up here? If I bring up all these problems, how can we help about it? I've told you, companies can't do this. They're not going to turn off particular functionality. They're not going to raise their domain functional level. They're not going to turn on delegated constrained delegation. How can we help? And how can we intercept and stop the transition between initial access, privilege escalation, and lateral movement? So about in 2020, CrowdStrike acquired a company called Preempt. We now call it Falcon Identity Protection. It is a solution that we have that basically applies the same concepts that we've applied to EDR to identities. Should this identity be doing what it's supposed to do? Is it something that's normal in the environment? And if it's not normal, provide a detection. And most importantly, the ability to provide preventions on malicious use of identities. It actually stops the attacker from doing things that they have the privilege to do if it doesn't look right. Also gives you data that allows you to proactively threat hunt across this information. You can put in conditional-based multi-factor authentication. One of the common things we see an attacker do, they get on a single box. I talked about MBT scan. They'll also run RDP scans. They'll look in the local terminal session event log to see where RDPs are coming into that system, and then they'll try to RDP out to those systems. For most admins, that's not normal. With something like Falcon Identity, it identifies that and provides a two-factor authentication prompt, multi-factor authentication prompt to the user saying, is this really you, yes or no? Stopping that attacker who all they have is the username and password or passing a hash right there in their tracks. So, what are you going to look for? I talked about all those things. Another thing that we offer is a CrowdStrike identity security assessment. It's really focused on the threat landscape. You've probably had somebody come in and look at your Active Directory and they say, cool, it's configured in a great manner. Here's this long list of things you need to fix. Every Active Directory assessment I've ever seen has pages and pages and pages of findings, most of which you can't implement because of business reasons. Identity security assessment really looks at how do you reduce that risk? What are the primary things that you should fix? Do you have bad account hygiene? Do you have a lot of domain admins? Do you have a lot of account operators, a lot of print operators? Do you have the right configurations across your objects and across your Active Directory domain? But most importantly, it looks at two things. Authentication activity. Is what we see in your environment normal and compared to similar organizations? Does it make sense on what's happening? And then looking at attack path analysis. How many of you have used Bloodhound or heard of Bloodhound? Very similar to what Bloodhound does, looking at the path an attacker would need to take to get from their unprivileged account to something that can own the network, whether it's domain admin or one of those operators that I talked about before. Help you reduce risk. A lot of organizations, we bring up that attack map to them and they go, I had no idea an attacker could do this. That I could add someone to this group and it would elevate their privileges to similar to that of domain administrator. So I think this is my last slide, and then we'll start some Q&A. But just to circle back on what we talked about, limit local administrator rights. Make sure that if you do give your users local admin, that it's restricted to their own workstation. Come in and have a red team test that. We have organizations that say, yes, it's only on that workstation. Red team comes in and they say, hey, I got this user and it just let me log into a domain controller. You have to try and you have to test these things. Require SMB signing, LDAP signing, LDAP-S signing, channel binding. Make sure that you have those turned on in your environment if you can. Make sure your different administrator accounts are using protected user groups. And the biggest thing is treat your operator groups as domain administrators. I see a lot of reports that say, hey, you only have 6 domain administrators. That's great. And then you have 7,000 account operators in your organization. Because you forgot to roll off all of your help desk people over the years. Use strong passwords for service accounts. There's no reason a service account password cannot be the maximum length that that operating system allows. No one should be using that password. You should be putting that in. Also know, and not up here, know how to change your service account passwords so that if they do get compromised. Every single investigation where we have to go in and do an enterprise password reset, they go, all right, we've reset all the user account passwords. We'll get to service accounts between now and 2027. And in 2027, they'll say it's going to take 10 more years. Because somewhere in hard-coded from a vendor that they hired 10 years ago, hard-coded that password in code. No one even knows how, where the actual source code is these days. And if they did, they probably wouldn't know how to, write that. We have COBOL, like we literally have users that still use that, or it's hard-coded in a script on an AIX system that's been pulling finance data for 15 years, and everyone's scared, rightfully so, scared to touch it. Every company has that system that you don't look at. It just keeps working, and you don't want to change anything. And every single one of those has an identity that likely will be compromised in a breach. Always require Kerberos pre-authentication. That'll reduce Kerberosian attacks, really make your network more secure. These are some of the simple things that you can do so that you don't have to call me. You don't have to call an incident response provider on a Friday. Back on the slide about ransomware, one of the things I forgot to kind of dive into is that we've seen, and you may have heard them talk about it yesterday in the intelligence panel, a fundamental shift in what ransomware actors are doing. It used to be we would go into a ransomware case and every system in the environment was encrypted. Now we go into a ransomware case and there's no systems encrypted. You're like, why is it a ransomware case? It's the same actors. It's the same affiliates. It's the same groups. They're sending a phishing email. They're getting access to one system. They're stealing as much data as they can, and then they're extorting the organization. And it's the compromised initial identity that is allowing that. So they're no longer, and some of them still are, doing enterprise-wide ransomware encryption, particularly on ESXi systems these days. But most actors, where they're making their money and where they're attempting to monetize the limited payments that are happening now is through the theft of and threat to leak data. And so knowing your identities, reducing what users can do, preventing that simple user from getting to, crown jewels isn't even the right word, but because they're not even caring about that, but they're just trying to get enough data that it makes the executives think twice about, do I want that leaked on the internet or not? But that's all my slides I have for today. Happy to take questions. If you do get a chance, I know the trade floor is open until I believe 12 or 1 today. We do have some demos up there, particularly around Falcon Identity. So, if you want to take some time, come up to the floor. We have some folks up there, and we're happy to walk in a lot more technical depth than I'm able to talk to.
I didn't have any questions. I was just going to add some pieces to what you're talking about. With local admin, you want to make sure they're not surfing the web.
Yeah.
And that those credentials are stored for 24 hours if it doesn't reboot. That's something I'm actually working through with some of our teams because we just found out, help desk will give them local admin. Once they reboot, they're good. Yeah, but if they work all day, they surf the internet, they get compromised. They're compromised at that local admin password.
Yep. Yeah, so if you're doing temporary local admin elevation for users, that local admin, that elevation will stay there until you revoke it and potentially have to restart that system.
Yeah, and the restart will also get rid of the Kerberos hashes that are hanging out there. The other piece you got to, and think about scanners as well. Your scanners running in with the domain admin credentials or elevated credentials, those are there for 24 hours.
Yep.
And 10 years ago, Metasploit had an impersonation piece where you can impersonate any credentials on there. Now I'm domain admin, I can do what I want. For passwords, beware of shares. We have a pen test team that actually is looking through shares, and especially on dev boxes, they will find production passwords and everything else. Your SCCM boxes, they'll find shares, and look, the SCCM team has passwords for things there, so be aware of those. And these are easy, they're open to all users because they have to be for some of the items. RC4 for Kerberos encryption, a lot of times it's there because you have not even 2003, 2012 servers.
Yep.
Domain controllers, and that's easy to crack.
Yeah, but those are ones that you can hunt through your logs for those. So you're going to see your 4624 events. Is that the right event? 4624 that has. Yeah.
But you got.
It'll show you RC4 in there.
But you may have more boxes doing it, so you got to look for the. Yep. It's got to stand out.
You see large volumes of those coming from a single box. RC4 Kerberos requests. You know that there's probably a problem.
And then one thing to be aware of. You talked about Bloodhound. Most tools, FireEye, Defender, all these will identify Bloodhound when it's run normally from the box. If you inject it into a process, you now can't see it.
Yep.
And so we're actually talking to some of our vendors about that because we had a red team test, and they injected Bloodhound in, so then we had to identify it from Kerberos traffic, which it's got to stand out enough to be noticeable.
Yeah. And that's one of those things that, a lot of these post-exploitation tools are finding ways to blend in or, potentially not have detection. So when you have those simple detections on a box that may be, actors operating, you have to not just investigate the detection, but investigate what else they may have done on that box. The great thing about EDRs, they're recording what's happening there, so you can look beyond the detections and see they may be doing something like that, injecting, Bloodhound into memory or other CrowdStrike into memory or things like that. So,
and the last thing I have onto that is service accounts. Get rid of the old ones. We've seen that where they've sat around. And then 15 characters, even with, capitalization, special characters and that, you can still have some really bad passwords. So just don't think that gives you any security.
Yep. Like the Wi-Fi password for the conference. It looks complex. It's not.
It's better than other ones they've had.
Well, thank you. Any more questions from the room?
So for your identity module, I believe you have a compromised password section.
Yep.
Can you give an overview of how that works? Is it a string match? Is it a hash match? Fuzzy hash? Are you transmitting passwords back and forth? You know what I mean? A little bit of overview on that.
Yeah, I don't know if I can speak to the specifics of how we're doing that. I know we use some of the publicly available lists. There's some internal logic that we have in there. I'm not exactly sure on the specifics of how our engineering team provides those lists, but on everywhere we roll out identity during an IR, it lights up like a Christmas tree because people are they're still using that same password that was, say, in the LinkedIn breach from 2010 or 12 or whatever that was. Users, they're lazy. They like to use their simple passwords. So that's a great thing about it. On one of the other slides, there's 11 billion passwords and have I been pwned. 11 billion variations of passwords in there. Like, it's likely that if your password is, at some point, every single person in the room could probably look up their email address, and it's probably on Have I Been Pwned. There's not many people I talk to say I have an email address that doesn't show up there, that's some site they signed up for. At some point in the history of their email was not compromised and leaked and then uploaded there. I mean, I know many of mine are from the past. All right, great. If there's no more questions, thanks for coming today. I hope you enjoy the last few hours of MWise, and safe travels back to wherever you traveled here from.